Well, what do you do when you have a noisy dust collector in the wood shop and a mountain of acoustic foam panels? Stick around, I'll show you what I've got in mind. Well, I wanted to show you the basic system that I'm starting with. It's a full-size 2-horse cyclone. It's got a really tall cyclone tower on it, and that does a great job at helping with separation. In fact, with this unit, I find almost ambient level of dust in the clean out at the bottom of the stack filter. And that's the best you can hope. There's just nothing to ever remove from that. It all goes into the chip bin. In fact, the only real problem I have with this system is just the noise. And part of that is where I located it in my shop. Really the best spot for me to have a clean 5-foot straight run as the inlet to the cyclone was to put it in this corner. Well, obviously with acoustics, if you put something very loud with a motor and a lot of airflow up in a corner, especially high up towards the ceiling, you're going to get a lot of reflected sound waves, and that's one of the problems in this setup. Another issue here is there's a tall filter and it's completely exposed. There's kind of a deep roar that emanates from the filter, and that sort of noise is not as annoying to me, but it's still something I would like to decrease the volume of. Probably the most disturbing noise is the reflected sound off the ceiling, and in fact there's a garage beam very nearby, so it's just a racket of reflected sound waves anytime you turn on the dust collector. Now my goal is not to be able to run the dust collector without hearing protection. Of course, I'm going to have a tool running anytime I'm using the dust collector, so I just want to decrease the volume of the sound somewhat. If I could achieve 5 to 10 decibels, I would be super happy with that. Okay, so we'll give you a quick baseline of what the sound is like with this collector, no modifications. Of course, I have added some basic insulation to the inlet and the outlet pipe, but that was pre-existing. I won't have decibel numbers on those. What we're going to be looking at is the change affected by adding a cover to the filter and a little soffit baffle up above around the motor. So here's the baseline, and we'll get you some decibel numbers. This is our baseline at 10 foot from the dust collector. No modifications at this point, and I've also cleared away the audio information when the dust collector is starting up. So there's no talking over this track. It's just simply the dust collector running at an average hum 10 feet away. Our baseline is 77 decibels, which isn't bad, by the way. I've seen some that are upwards of 80 or low 90s. So with this 2-horsepower cyclone, I think we're starting in a pretty decent ballpark. If we can improve this 5 to 10 decibels, that would be fantastic. The first thing I wanted to test was if a baffle around the exit filter of the cyclone would make a significant difference on the noise level or the quality of the noise. So I made a quick styrofoam baffle and loosely surrounded the filter, and that resulted in a 5 decibel drop in the sound. So early tests are promising. We'll build something a little more permanent. Okay, so here we're under construction with the deflector shield that's going to go around the exit filter for the dust collector. We've got it lined with these acoustic panels and even some bass traps on the corners where it'll fit. And it's just kind of an L-shaped structure that we made from OSB. We've coated it with the soft panels on the inside and then thinner, rigid panels on the outside, so we'll get a look at the outside as well as it's installed. So here are the thinner, denser panels that we put on the outside. They are sold as acoustic panels as well, but you know, they're less than a ½ an inch thick, so to me these are not great at dispersing sound. They're just better at preventing sound from passing through a wall. So that's kind of how we've used them here. Coat the outside of the shield with these thin panels and it'll just block that much more sound. At least that's the theory. So there's a good amount of acoustic foam attached to the wall behind the shield as well, and I think that does a really good job to just kind of capture some of the sound before it exits out the top. But other than that, it's not sealed on the top. Air is free to escape through the top side, so it won't limit the effectiveness of the collector. Let's take a quick look at the top of the deflector shield so we can see how it's surrounded by the acoustic panels, both against the wall and the inside dimensions of the deflector shield. And now we've coated the outside with the thin, dense, flat acoustic panels on the outside. Okay, so with the addition of the thin, flat acoustic panels on the outside of the deflector shield, we're getting readings of 72 to 73 decibels when we're about 10 feet away from the collector. Now this is with one gate open, the same as each time we've tested this. And what I will note is that initially we got readings of 77 decibels. But then right after I took that measurement, I gave the filter a good cleaning because I was just doing some maintenance on the system. And what I noticed was the decibels immediately rose to 78 as our baseline after the filter was thoroughly cleaned. So I'm going to use 78 as our base number. And if we're in the 72 to 73 range, just this deflector shield has decreased our sound volume by, let's say 6 decibels at most. It's a good start. I think we can do a little better with the soffit up above, so we'll keep working. Okay, so just a quick peek at the construction of the soffit baffle. We've just framed in with basic 2x4 construction the upper part of the cyclone, and at this point it's enclosed with some OSB on the bottom, painted black. Now of course all of the cavities in here have been covered with acoustic foam panels, and there's even a couple baffles, so I'll get up on a ladder and show you the baffles a little closer. They're right over in this area. Basically this left side of the soffit baffle is going to be left open for ventilation, and so as it passes through there's a couple of baffles here. The air can go under this and it can go over that, but there's no straight output for the sound level. And so just by directing the sound around a couple of corners there, I'm hoping to soften the sound somewhat. We'll go ahead and button up this face panel, another black painted piece of OSB, and we'll test out the sound level. Okay, so with the addition of the soffit baffle overhead, we were able to achieve about 70 decibels compared to our initial test of 78 decibels right after we cleaned the filter. We're seeing a maximum of 8 decibel drop, but qualitatively it's quite a big difference. I'm keeping in mind that every 10 decibel drop is basically cutting the sound volume in half. So if I can drop it 8 decibels, I certainly think it's a quieter system. We'll give you a listen and see what you think. And that is much quieter overall. It's going to be a much more pleasant shop experience, I think. Okay, so we finished up all the modifications to quiet down our dust collector. The overhead soffit baffle and the deflector shield, the baffle that covers the air filter exit. And I would say it made a significant difference. Would I do it again? Yes, I think I would. Now, is this going to make the same amount of difference as framing a wall that's insulated and enclosing your dust collector behind that structure? No, I don't think it's going to make that level of difference. But it will make an appreciable difference in both the quality of the noise and the level of the noise. We saw an 8 decibel drop in the sound level. Knowing that every 10 decibels is approximately cutting the sound in half, I think that's definitely worth doing. So if you can get your hands on some acoustic foam, I really recommend trying this project. Thanks for watching. We'll see you next time. And Trooper appreciates it too.